So before midterm, we have seen how to construct a PDA, right? That's all we have seen. So now from today, so from today onwards, right, we'll be seeing the relationship between push down automata and the context free grammar. And then okay, so what we'll be seeing is that the relationship between push down automata and the context free grammar. And then at the beginning of the context free grammar classes, I have already told that if you want to construct a push down automata for a particular given context free grammar, then you have to convert that context free grammar to the Gravec normal form. So if you have the context-free grammar in the Gravec normal form, then only you can directly design a push-down automata of a given context-free grammar. Okay, I'm just reminding you what I've told at the beginning of the classes regarding context-free grammar. So today what we'll be saying is that I'll be just using the term context-free grammar instead of using Gravec normal form again and again. Okay, but by default, you have to understand that if I say design a push-down automata for a given context-free grammar, by default, you have to consider that yes, you have to convert the grammar into the Gravec normal form, and then only you can proceed. Okay, that's advice from my side. So now, today what we're going to see is so today regarding this today's topic, right? We are going to construct a push-down automata equivalent of a CFC. This is today's topic. Okay. So in textbooks and all, you can find the push-down automata and context-free grammar. Okay, or so like that. So let me give for a given context. So for that push-down automata. So let me just recollect it. So let me represent this P automata by P. We know it's a construction of this. No need to explain what are these symbols representing in here because this is already explained to you guys. And then let me recall the grammar also. Let me recall the grammar also. Oh. MTES. Now, given a context-free grammar, we have to construct a push-down automata. So in the push-down automata, right, this Q is representing a collection of states, okay, a collection of states. Now, for simplicity purpose, right, our target is to design a push-down automata for this particular given context-free grammar. So we need to have a state. If you want to construct or if you want to design a push-down automata, we need to have a state. So for simplicity purpose, always try to simplify the problem, okay? Do not complexify the thing from the beginning so that it will be easy for you guys to understand it. Okay, that's why for simplicity purpose, let's assume you having only two states, that is P comma Q. It is our assumption. Okay, if you want to, if you're going to design a push-down automata by accepting the final, by reaching the final state or something, you can consider Q as the final state. It's up to you. Okay, it's up to you. So for me, right, we are going to consider this Q is having only two states, that is P comma Q. And then other symbols, right, we need to define it as per the grammar provided to us. So input symbols will be equivalent to T from the grammar. And then this step symbol or stack symbol is right. This will be AND union T. And then initial state, let me consider this. If you want to design a push-down automata by reaching the acceptance, by reaching the final state, you can specify the final state. But in my case, I'm not going to specify the final states because I'm planning to design by emptying the stack. Okay. Even though if it is mentioned F in here, you can declare this as 5 or something. It's up to you. Okay. Now and then, after recreating the tuple in here from this in this particular push-down automata, right? So this had been linked from this grammar. Might be confused for you guys a bit. Once we start taking the examples, you'll be understanding a bit. So don't worry right now. Let me just write the rules first, and then I'll just take the example. And then here comes the transition function. The transition functions, right? Initially, I have considered P as the initial state. So initially, I'm considering everything is empty. Q comma S. Okay, where S belongs to set of non-terminal of the CFC. When you are being supplied with grammar, right? Definitely that grammar will be having a start symbol. So that start symbol is nothing but it's a part of non-terminal, set of non-terminal. That's why I have mentioned S belongs to a set of non-terminal. Okay, don't get confused. And then next one, from the initial state, I have transferred the state from P to Q. So next time, right, we'll be assuming only Q state. I guess I don't have to specify the things which I've written right here because this is already discussed before midterm. For each reduction A in shapes. For all the production rules provided to us, right, we have to write the transition function of that one. That's why I have constructed, I have written like this. Number 3. For each A belongs to terminal. Don't worry, I have written the rules here how to construct a push-down automata from a given grammar. So next I'll be taking the example. Let me just consider an example. G is equal to N comma P comma T comma S, where N, S, T, then production S replaceable by epsilon. Then let me actually, you already know, like we can combine these things like this. Okay, or we can write like this. Let me just mark 1, 2, 3. Okay, once you understand the construction of PDA from a given CFD, please avoid writing in this format, like how I have written 1, 2, 3. Okay, I'm just treating you guys as a beginners. That's why I've written like this. But once you know the concept, please avoid writing like this. Okay, it's not a good thing. So now, given this particular context-free grammar, we are going to design a push-down automata. We are going to design a push-down automata using the rules which have already written in here. Okay, now let me just start the construction of push-down automata. Solution. Again, we are going to assume that let us assume the who q comma this transition this q not this where q will be this, summation will be as per the rules, the summation, this input symbol is T. Okay, as per the rules, it's T. So in our case, T is what? This one. So let me just write like this. And then this one is equal to this as per the rule. So let me just write S comma this comma this. Okay. And then next one is initial state. Q naught is equal to this. Okay. And then final state, I just want to specify the final state. So let me just specify it. While writing the tips, I have told that it is up to you. It is up to you. So I'm declaring the final state as Q. Now, in order to complete this, we need to write the transition function. Transition function as per the rules which I have written out here, right? Initially we are assuming that the read-write head is in initial state, which is P, and then input tape and then stake are empty initially, and then we are pushing this stake symbol S inside the stack. Okay, so let me just do that. E comma epsilon Q comma S. This is first transition function. And then next, what we have next for all the productions provided, right? We have to insert a transition function of this format. Derivable by, replaceable by terminal X. If you have such kind of production rules, then you have to insert a transition function of this kind. So how many production rules are available to us? For that, we have to insert. So totally 1, 2, 3 production rules. So for all these 3, right, we have to insert 3 transition functions. So now let me insert it. As per the first transition function, the shift has been done from P to Q state already. So we'll be proceeding with Q as the current state. And then as this one, I'm following the rules. Okay, this one is for S replaceable by epsilon. And then number 3, Q. This one for S. These are being done as per the rules. Okay, don't get confused. Q epsilon S, then Q is being done. Okay. As per the rules for the second one, right? What we did for all the productions given to us, we have inserted the transition of this format. Okay. Now, as per the third rules, for writing the transition function, what they have written here say it. For all the terminal present in this capital T, which is set of terminal, you have to insert the transition like this. Okay, so let me just start doing this. Bracket. This is not C, that's first bracket, Q comma epsilon, where this bracket belongs to T. And then number six, this is first bracket, close one. This belongs to T. And then number seven, any other? Any other terminal exists? Any other terminal exists? Any idea? Inside this terminal, we have open bracket, first bracket, open bracket, and then first bracket, close bracket. Okay. For all these two, we have inserted like this, hence no need for this. Okay. No need for this. So this is the way how we should be designing a PDA from a given CFG. Let me take another example. This is it, okay. Whatever the rules being provided to us, we have done the same in here with this particular example. Now let me take another example. With that example, I'll just end the session. Don't get confused, just follow the rules. Let me take another example. In this example, let me just write the production rules straightly as A S A, capital S, this C. Okay. In this case, let me just terminal as A, B, C. And then for simplicity reasons, let P is equal to Q, this, Q naught, transition, this R. So for simplicity purpose, Q will be consisting of E, Q, and then this will be equivalent to T, which is nothing but A, B, C, and then this will be equivalent to N union T. So in here, N is S, A, B, C, and then we can consider Q naught as equivalent to P, and then we can consider F is equal to Q. Okay, and then for this one, right? For push-down automata, all the elements are being specified in here. Now the only one which is being left out is the transition function. So in order to fill this transition functions, right, I need to follow the rules which I have mentioned earlier. Those three rules we need to follow, and then we need to construct the transition function. Okay, don't get confused. Just stick with the rules. So now let me start writing the transition function. Yes. Oh. So let me just start writing the transition function. So number one, as per the rules, initially we are considering that everything is empty and then we are shifting state from P to Q and then pushing S inside the stack. So we'll be doing the same for this one also. 1 is equal to initially at P input tab empty, stack empty, and then we'll perform the transition from P to Q and then push S. Okay. And then number 2. In number 2, what we have seen is for all the transition function, for all the production rules provided to us via that context-free grammar, we have to insert the transition function of this format. Okay, let me just do it. Let me just do it. There are three transition functions being provided to us. There are 3 transition functions being provided to us. So let me just write 3 for all. So what are the production rules provided to us? S replaceable by A as A, then B as B, then C. So I have to write all of them here. So let me write here A as A, B as B, and then C. This is as per rule number 2. Let me just write S this will by A as A, this is for B as B, this is for C. Okay. Now, as per the rules number 3, what we need to do is for all the terminals provided to us via this context-free grammar, we need to insert transition function of rule number 3. So let me just show you rule number 3. So as per rule number 3, for all the terminals present in this set of terminal, you have to insert a transition function of this kind. So let me do it. How many terminals are here? 3. A, B, and C. A, B, and C. So for that one, Q, comma, A, comma, A, Q, comma, B, comma, B, Q, comma, C, comma, C. One, right? Q, comma, epsilon. This is the end of today's topic. Today, what we have learned is, given a context-free grammar, we are designing a post automata of it. Okay, so practice well. Once you go back, please go through the textbook. Lots of example has been provided in the textbook, so do practice a lot. And then one more request to all. I have uploaded poster and all in the group. I'm expecting at least 20 participants from you guys. And for the first event, the last date, which was March 10, right? Many requests are dropping in from other participants, from extending till 15. So from your class, I'm expecting at around 20 to 25 participants. Do participate it, okay? I'm the organizer for that one. Okay, fine. Bye.